Hello, everybody. Thank you for joining this webinar today. And thank you to LiDAR Comex for organizing it. So this webinar is being recorded, so you will have a chance to view it again on Cintoo's YouTube channel. And also, there will be a Q&A session at the end, of course, but feel free to ask any question in the chat box. My colleagues, Rob and Bill, will be answering those questions while I will be speaking. So I'm Dominique Pouliquen. A little bit about myself. I've been 35 years in computer graphics, including 24 years in reality capture. All started 1998 by the creation of RealViz. RealViz was the first ever photogrammetry engine being released as a product. Product was named Image Modeler or Match Mover. We call it also the Image Processing Factory. This is a company that I sold to Autodesk in 2008. Eventually became Recap Photo. Some people may have heard about Recap. So I was product manager for Recap Photo, Recap Pro at Autodesk for many years in San Francisco. And then I co-founded, I'm CEO now of Cintoo. I will tell you more about Cintoo, of course. I'm acting as a product manager for the platform called Cintoo Cloud. So this is why I will be showing what we do today on a little bit of what is coming as well. So this is the agenda for today, for today's webinar. I will be starting by introducing Cintoo Cloud to you with a set of short demos so that you can see the technology in action. Then I will go a little deeper how we upload terrestrial scans to Cintoo Cloud. And then what is new today, I'll say how we upload also now mobile scans coming from devices like Navis VLX, Viametris, or BLK, Leica BLK2Go, and many others. And we do that by restructuring unstructured data, which is a very new process. So I will explain how we do that. And then I will show you also a glimpse of what we will do for drone data. This is more like a preview of what is coming in Q3, but I will show you an example data sets combining drone data from photogrammetry plus static scans. And finally, I will show you how to export scan data from Cintoo Cloud, either as a point cloud or as a mesh. And as a final set of slides, I will show you a few new features that are coming in the next 2 to 3 months. So let me start by introducing Cintoo Cloud to you. Cintoo Cloud is a company that is positioned at the convergence of digital twins and reality capture. It's a spin-off from a lab in France that developed a unique technology where we're able to take huge point clouds coming from static scans and turn them into a high-resolution 3D meshes. And those 3D meshes can be viewed in a web browser, can be streamed in a web browser as well. And doing this point cloud to mesh transformation has many objectives. The first objective is the compression of the source data. You all know that static scans, point cloud data is very huge, massive. You have terabytes of data for a single project. So it always, it often ends up in a hard disk that sits on the desk somewhere. Nobody can access this data. So what we do, we will make this point cloud data about 10 to 20 times smaller in size. Then we'll be able to upload it to the cloud. But not only we make it, but this compression that we do, point cloud to mesh, is with no loss of accuracy of density. The mesh you will be viewing in the browser, it has the same resolution and density than your source point cloud. We also keep the structure of the project. So the mesh also has another advantage. It will make your data much easier to view and interpret. Okay, so it's all about democratizing access to point cloud data. Very few people access to this trustful information. So by using a mesh, being like somehow a video game, we make many more people being able to use and access this very interesting information and extract meaningful information from it. Not only that, we have the unique capability to turn back the mesh into the source point cloud. So we can do the inverse transformation, bringing the mesh back to the original source point cloud, being a structured or unstructured point cloud. Because at some point you may need to distribute your data to people that will use software like Revit or AutoCAD or Navisworks, in which you will need a RCP file to be able to snap to the points. And this is a unique patented technology, point cloud to mesh, mesh to point cloud, that we have developed over many years. So this technology is embedded into a platform called Cintoo Cloud that will make your laser scans fully cloud compatible. That means you can access them from anywhere at any time. You can, of course, do many other features. You have the capability to enrich the data with measurements, annotations. We can also cloud connect to other BIM platforms like BIM 360 from Autodesk. You can pull a BIM model, overlay it over the scans, do comparisons. There are many interesting features that I will be showing to you today. So Cintoo Cloud runs exclusively on Amazon or Azure. And you have this unique feature that we have as well, where you can select the data center where your 3D data will be hosted. So if you have a company in the US and you want the data to stay in the US, we can do that. If you have a job now in Europe, or you want the data to stay in the UK or in France, you can just select the data center from Amazon or Azure in those countries, and you make sure that the data stay there. We're also SOC 2 Type 2 certified. That means we are at the highest level of cybersecurity standards for the US. So this is really a trustful and reliable platform you can count on. So we primarily serve all kinds of digital twin industries, those digital twin industries that have been using laser scanning for many years, like automobile, oil and gas, energy, manufacturing, but also, of course, BIM and construction. And we serve those industries with three key value propositions, which all come with a set of features, of course. The first one on the left-hand side is the capability to share, to collaborate on your laser scan data in a web browser with no plugin to install, with this mesh viewing, making it much easier to navigate and interpret. So it's all about collaboration, sharing, distribution, making measurements, adding annotations to your laser scan data. Being able also to organize your scan data, so you can manage user access to various regions of your scan, etc. The second value proposition is all about quality control. So being able to compare the existing conditions coming from your laser scan data to your BIM or CAD model, being able to detect issues and document those issues that you can push back in your documentation platform or your model coordination platform. And last but not least, it's all about asset management, being able to display your equipment in their existing conditions, be able to connect this visualization to your digital twin platform or your documentation platform. And this is a new set of features that we are going to release in the next few weeks. So this is basically the ecosystem we live in. So we'll take your point cloud data from any source. We don't do the registration. We don't do the alignment. So this is supposed to happen in your favorite registration software, being Recap Pro, Pharocene, Leica Cyclone, Register 360, Trimble Rearworks, etc. Or if it's a mobile scans, the SLAM process is supposed to be done by your Navis software, your Volumetry software, Gexel, etc. Okay, so we'll take the data after it has been registered. We will turn it into high-resolution meshes. On this, I will show you how we do that. We cloud connect to other BIM platforms like Autodesk BIM 360, BIMTrack, Procore. And when it comes to getting back your data in the desktop world, like in Autodesk, Revit, AutoCAD, or Navisworks, you can do it either as a point cloud or as a mesh. This is how we do that. So the workflow is the following. We will take the data as structure or unstructured point cloud, and before uploading, we will run this Cintoo Connect Windows app. I will show you how to do that. That will do this point cloud to mesh transformation and upload. So everything uploaded to Cintoo Cloud is mesh-based. When it comes to distributing back the data in your desktop world to your colleagues, you can do it as a mesh, you can do it as a point cloud, and if you do it as a point cloud, we will do the inverse transformation locally on the computer of the person that requires that. It will use the same Cintoo Connect Windows app to do this mesh to point cloud, and then he or she can get a unified or structured point cloud in various formats as well. I will show you these details. When it comes to cloud connecting to BIM 360, this is where we pull either IFCs or Revit or Navisworks model or DWGs as well. And we can push back issues on report and analysis back to this platform as well, including also Procore on BIMtrack. So it's all about streaming high-resolution 3D meshes in a web browser. You can do that on the desktop, on laptops, on the tablet. We can also do that in Unreal, on Unity. Now you can stream those high-resolution meshes in game engines to create very rich media, rich scan on BIM or scan on CAD experiences that can be immersive or collaborative. So Cintoo Cloud has been on the market for a few years now. Very robust, very stable platform. We serve more than 320 companies now in more than 32 countries. Big groups on the service providers, engineering companies, all kinds of industries. They have uploaded almost 2 million scans now to the platform. We have more than 24,000 users. So this is something you can rely on. So let me go to a quick demo. I will be using a first dataset here provided by our good colleagues at SSOE, an engineering company based in the US. So let me click on this one. I will go to Google Chrome. So here I'm using Google Chrome as a web browser, and I will connect to my projects here. So the first way to browse your projects is via a map. So you can see all your projects on a map like this, or you can also view them on thumbnails via thumbnails here. And as I said, when you create a new project, this is where you can decide. Of course, you need to give a name, a geolocation, something like that. But this is where you can decide to host your data in any given data center on Amazon or Azure. So let me show you this first demo. Let me look for a project called this one. Okay. So this one is interesting because it has various layers of information. Of course, we have scan data. And the scan has been spread over various what we call work zones. We have 471 scans in this one that have been spread in various folders called exterior, gym level 1, gym level 2, etc. You see the kind of arrangement we have with the scan data here, and this is very easy to do in the platform. So let me show you one of those scans. This is a 10 million point scan from Faro. I click on it. This is a high resolution panoramic image. You're very used to this one. But what we did with this technology is that we turn it into a very high resolution mesh. So when I go on Play 3D, I go to the 3D view now. First thing I will see, of course, is a panoramic image, and I can navigate scan to scan. Very typical of using laser scan data. But now I can also use any one of those 3D shaders. Let me show you the 3D surface. This is where you will see the high resolution 3D mesh that we built from the point cloud. And this is really where our technology shines. This mesh, and the more I zoom in, the more I will be streaming levels of details for this particular point cloud. And the more points you have, let's say you scan with 40 million points instead of 10 million points, or even 160 million points per scan instead of 10 million points, the more points you have per scan, the denser the mesh as well. So you will be able to zoom in and see even more details. And this is exactly what this technology is all about. It's about revealing details that you have probably never seen before in your own laser scans. Of course, you can see that with the color as well. You can always go back to the 2D panoramic image. On here, you see one good advantage of using this technology. For example, here you see that the panoramic image is completely overexposed, but the laser beam was able to capture this geometry. So you will see that in the 3D surface mode. Okay. Of course, this is a kind of mode. Surface mode is being used to make any kind of measurements. You can have various types of measurements, being a freehand, constrained by the x-axis, y-axis, or z-axis, or constrained by a flat surface. Let me take a measurement from the roof, for example, to roof to the floor here. Very easy. And then you can save the measurement. It will be saved with a thumbnail. So whoever will come back to this list of measurements will be able to click on it and see the exact measuring conditions. You can also use this view to make annotations. You click add annotation here. You click on any 3D point here, like this lamp here. Say this is it could be a note, it could be a private note, could be an issue. If it's an issue, you give it a title, of course. Lamp to be removed. And then you can add various metadata like a severity parameter, a due date eventually. You can add text, photo, video, PDFs, hyperlink. You can also assign it to team members, and then you create the annotation. All the same, all those annotations are saved with a thumbnail, so whoever will click on them will be able to see this exact annotation. Okay, so this is what we have, but let me show you the complete project now. The complete project comes here with various layers of information. Not only we have scan data, but we also have what we call a sitemap. The sitemap is this Google Earth view. We have a BIM model, we have 2D drawings, and we have scan data. So for example, let me remove the sitemap. Let me remove the model. So here we have scan and 2D. Or if I remove the 2D as well, here you have scan data only. So very easy to navigate, very easy to overlay scan on BIM. And let me show you another example to see what you can do when you have scan on BIM data. Coming back to this deck, so I will be using another data set coming from our good friends at TruePoint Laser Scanning. Let me click on this guy. So here we have a very similar data set that has also scan data, 2D drawings, 3D model on a sitemap. So here I started by the east side. So when I click on one of those folders here, I will be streaming only the 24 scans corresponding to this exact work zone. Okay, you see this, how fast we stream those 24 scans here. Just one trick here, you use the surface mode, you can eventually go to the backface culling. Backface culling will show you always the inside of your building from any angle, because in this case, with the backface culling, we don't display the surfaces that are not oriented toward the camera. So from any angle, you will see the inside. You see, this is pretty cool. In recap, if you want to view the inside, you have to clip data, you have to remove points to see the inside. Here, you don't need to do that. Let me, for example, add the 2D drawing now. So here we have scan data and 2D. This could be already useful for some analysis. For example, here I can take a top view, go for orthographic view. And here I can activate the X-ray vision. And with X-ray vision, you will see the overlay of your CAD data, 2D data, and your scans. You can go into the details, see if your scans fit your 2D drawing on your 3D model, etc. So this is already some kind of analysis that you can do here in the 2D space. But let me add now the 3D model. Let me go back to the surface mode on the perspective view here. So here I have scans 2D and 3D, and I will go into one of those scan positions. I will move to the scan mode. So here I'm in one of the scan positions. And from these exact vantage points, what I can see here is scan, BIM, and 2D. Now let me move to this particular location here. This one is interesting, because here you see there is a model, there is an existing condition, there is 2D here. You can also see in the navigation map here down below, you can navigate your scans this way over the 2D drawing. But here what I can activate as well is a comparison tool. So if I click on the comparison tool, I say I want to compare my scan data to my model, and I have two tools here. The first one is called the Visual Diff tool. By activating this one, we will create a heat map that will give you the differences between the existing conditions on the BIM or CAD model. in a given tolerance, which is about 3 inches here. What you can see clearly here is that everything in green is a good match between your BIM or CAD model and the scan data. Everything in red is data that is the existing conditions that is not in your CAD model. And for example, you see that the door here is red on about 1 foot. If I go to the visual check tool, I will be able to play with the transparency level. So if I put my slider to the left, I will see the existing conditions. So this is my mesh coming from this particular scan position. And if I put my slider to the right, I will be able to see the BIM model on the 2D model. And you see that there is clearly a mismatch here. The door is not in the BIM model, is not at the exact location, which you can also see in the 2D drawing. Let me remove the BIM model now. On here, I can compare my scan data to my 2D drawing. And you see the door is not at the right location. Let me put back the model. I can go back to the visual diff tool. So what I want to do next is document this issue. So I will go to the annotation tab, create an annotation, click on this 3D point here, say this is an issue, door to be adjusted in BIM. You say this is very critical. It should be done, but should be fixed by the end of the month. You can put photos, videos, hyperlinks, whatever here, and I will assign it to a team member eventually, like my colleague Alex here. I just validate that he can access this work zone, and then I create the annotation. Okay, and those annotations now will be all listed in the report tab. This is the one I just created, but there are others, you know, etc. On those annotations, those issues can be exported either as PDF file. This PDF will contain also hyperlinks. So when you click on the PDF, it will take you back to Cintoo Cloud, or as a BCF file, which is an XML file called BIM collaboration format. And you have plugins in Revit or Navisworks to be able to read those BCF files, or Revisto as well. Or you can also connect cloud to cloud. We have done these cloud to cloud integrations with BIMTrack, BIM 360, and Procore. So you will be able to push those annotations cloud to cloud to those other platforms for model coordination. A few words about users and permissions. This is a list of users and permissions. So this is my list of users globally. I can group them in groups. And when I assign them to a given project, this is where I will be giving them, each one of them, a role that comes with permissions. So for example, I can invite someone on the project as a BIM manager, in which case he will be able to do everything on the project, including organizing the data, inviting other team members, etc. Or I can invite him or her as a viewer only, in which case he will be able to view the data only. Okay, so this is a quick overview of what the platform can do. There are many more. We have sharing options and things like that, but I don't want to take too much time. If you're interested anyway, the best way will be to try the platform on your own data set, and I'll give you the information about that at the end of the talk. So now let's move on. The first one I wanted to highlight is how you can upload easily terrestrial scans and then mobile scans, which is a new feature we just released lately. So uploading terrestrial scans is very easy. I'm talking about this piece of the workflow, okay, where you have structure scans that have been registered, let's say WCAP Pro, Faroscene, Register 360, whatever. So you'll get a E57 file or RCT file that are structured. It can be a FLS file as well. On how does it work? When you create a project, the first thing you will see is this list of possibilities. You can add data to your project. First one will be scans, but also this is how you upload models, by either connecting to BIM 360 or by uploading IFCs. You can also enrich your project with documents, 360 images, or assets. So talking about scans, when you click on prepare and upload, this is where you start Cintoo Connect on your computer. So this is Cintoo Connect. This is a Windows app that can be only started from the web app. You have to be cloud connected to Cintoo. You have to be registered. So you select this tab here called terrestrial scans. You will be able to select your input files, being RCP, E57, FLS, LSPROJ. And this is where you see your list of static scans being listed here. You can also select how many scans you want to process in parallel. Think about it. It takes about 1 minute per 10 million points to process this point cloud to mesh engine. Okay, 1 minute per 10 million points. So if you have a multi-core machine, you will be able to process many scans in parallel. So it can be pretty fast. It's also a batch process. You can run it overnight. So it stops doing the process, point cloud to mesh conversion. At some point, it's ready. The data has been converted. So the upload will start in the work zone that you have selected, and it will process all the other scans the same way. You can also access your scan details here. Here we see that this is a 10 million point scans, 1.2 million scans. You have the exact location and rotation, etc. So this is how you will run the upload of the terrestrial scans. Pretty easy. Again, feel free to try the platform with your own data. Let me speak more about how you upload mobile scan, because this is a very new feature that we just introduced 1 or 2 weeks ago. So by uploading mobile scans, we mean data coming from either the Navis, DLX, M6, the GeoSLAM, MScent, Leica BLK2Go, Biometrics device, or Gexel device. What we get from these devices after you have run the SLAM process is a point cloud. It can be E57, for example, or PLY. You get a point cloud, and also we get the camera pass on the source panoramas. This is all we get from you. And what we will do, the process is about turning this unstructured data into a structured data on which we can apply the same core algorithms that we have for static scans to turn them into meshes. So the way it works is the following. So we get the raw point cloud and camera pass. The panoramic images are optional. If you have them, this is great. We will be able to display them. If you don't have them, no problem. We will create panoramic images from the point cloud. Then we will ask you to sample, but this is done automatically. We say, okay, I want a 3D virtual scan every X meters. Okay, it could be 5 meters, 10 meters, it's your call. Okay, and then for each one of those scan positions, we will create a depth map. We will take into account only the visible point for each position. Finally, what we have at the end of this process is for each virtual 3D scan, the exact same information as we have from a static scan, on which we can apply our core compression, multi-resolution meshing technologies so that it looks like a static scan. So the advantages of doing this process are really, really interesting, because of course, what we do with this process, we keep the precision of the original point cloud. We generate a panoramic image no matter what, either we use a panoramic image coming from the device, or we will create a panoramic image from the point cloud. But the main user advantage is that we will make your data much easier to navigate and much easier to interpret thanks to the meshing viewing, to the mesh viewer. And these are really the key benefits of doing this process. You can also now have in a single experience, the same experience navigating your static scans, your mobile scans, and even your drone scans. And you can even now download back or distribute back your mobile data as structure files that will come with a panoramic image that you can display in Recap, for example. So let me show you a few examples of this. First example, let me show you first how we do this. So we'll use Cintoo Connect all the same. You will select this indoor mobile scan tab here, and then you have 3 types of information. The first one, mandatory, is of course your point cloud, which is the one created from the SLAM algorithms provided by the device manufacturer. We'll also get your scanning path. It could be a generic CSV, or we also read the TXT file from GeoSLAM, the CSV file from Navis, and the XYZ file coming from Biometrics. Soon we'll be adding MScent. For the Navis case, we also be able to read the XML file. In case you have done multiple paths, you need to put them in the same coordinate system. And this is what the XML file is all about. So let me show you an example using Navis VLX, again, courtesy of my good friends at Point Laser Scanning. Clicking on this, so opening here the project inside Cintoo Cloud. You see here we have 341 virtual scans, okay, here that are listed here. Let me go into the 3D view here. Here we have a BIM model as well. Let me remove the BIM model to see the scan data only. So this is your data coming from the VLX. Let me go into this scanning position, for example. So you see here, you're now able to navigate scan to scan with these panoramic images created from the device. But of course, we turn that into a 3D mesh as well. So when you go into the 3D surface, you see this mesh data, as if the data would have been captured by the static scanning. And then you can add your Revit model, use a comparison tool, again, select scans, models. Here you see a few issues. For example, you see that this pillar here is all red because when you go into this visual check tool, you see that the existing condition has shown a pillar, whereas the BIM model doesn't show a pillar, okay? So really useful information. Now also, you can also, let me refresh this. You can also view, have other views of this BIM and scan data, like in the orthographic mode. So go back to, let's say, the top view, use orthographic mode, go to the 3D X-ray vision mode, and you see the interesting information you can get here. Okay, so this is comparing scan on BIM. You can take a side view of it. Really interesting details here, comparing your BIM model on your scan data. So this is what we have for the VLX. Let me show you now data from the Viametris BM S3D, which is a really good device. It's also a backpack mounted device, same as VLX. If I click on this one, I go to this data set now. I strongly feel that the panoramic images and the geometry you get from the Viametris device is better than the VLX. You should take a look at this one. So this is a data set. Let's go to the 3D view. So these are all the scan data. Let me go into the scan mode here. So the scan mode, you see the panoramic image, very high quality panoramic image, no distortion at all. Let me switch to the next one here, so you can easily navigate your mobile data now. And let me switch to the 3D surface mode. You clearly see a lot of details now, okay, that were otherwise very difficult to see. And you see that the geometry you capture with this device is really amazing. So very good alternative as well. So consider Viametris as an option as well. Will give you very good details. Let me switch to the next example here. The next example will be the BLK to go. I got this dataset from Leica. On here, I would like to show you how it looked like in recap on how it looked like inside Cintoo Cloud. This is a kind of preview because this importing BLK to go data is not completely available yet in Cintoo Cloud. It will come with Cintoo Connect 2.1 due for Q2 for this next few weeks. On the Leica side, if you want to get, they have done a good job at exporting a single E57 file that contains a point cloud, the panoramic images, and the camera paths. But in order to generate this E57 file from Register 360, you will have to use the latest version of it, Register 360 2022.0, that has this command line interface. And then you will need to have Publisher Pro to be able to run this command line interface and get the E57 with the right information. Once you have that, you have very good data inside Cintoo Cloud. And we also get the panoramic images coming from the device. So these are not complete panoramic images, as you know, from the BLK2Go. But anyway, when you go into the dataset now, you really have a good 3D data that you can navigate scan to scan, again, with panoramic images. Or 3D mesh. Which makes your data so much easier to view and interpret and to navigate by non-experts. Even here, this BLK2Go was able to capture some detailed geometry. Let me show you the same data in recap, just to give you an idea of how it looked like. In recap, so opening recap now. Recap, a very good product, of course. I was in charge of it a few years back, but this is the same data. And again, the navigation is much more difficult. You don't have vantage points, so you have to navigate in the full 3D space, which is not so easy for non-experts. And again, this is the kind of data you have comparing to this kind of view. Okay, of course, you can get the color aspect of it as well here, but the 3D surface really makes a big difference. Let me go back to my deck here. Next one I wanted to show you is an example of drone data. We will apply the same process for drone data. I mean, drone data, I'm talking about the photo on drone, so data being processed by software like Drone Deploy or Pix4D will give you the same point cloud on camera path. So what we will do all the same, we will get your point cloud coming from the photogrammetry process, being recap photo as well. And then we will be able either to get, if we get the camera pass, fine. If we don't have the camera pass, no problem. We will propose a grid. You will be able to tell that you want to have a 3D virtual 3D scan every X by X meters at a given altitude. Okay. And this will come with Cintoo Connect 2.2 due for Q3. So not exactly in the next few weeks, but in the next few months. But here I have an example of that. Courtesy of Scopus Engineering, a good friends in Norway, doing great work with Cintoo. And also you see that Scopus have got what we call our custom branding. So we have the capability to customize the user interface of Cintoo to your own logo. So let me click on this project. I will be logging into Scopus now. Here you have a mix of drone data. We created 34 virtual vantage points here, plus about 600 static scans. So when I go into the 3D view now, I will be able to navigate between static scan and drone scans. So let me go into the scan mode here. So this is like a first panoramic image. It looks like a panoramic image, but this panoramic image was created from the point cloud. We didn't have any information about the photo. And look at the quality of the panoramic image we were able to create. And of course, this is a 3D data as well. If I switch to 3D surface mode, you will see the high quality mesh we got from this point cloud coming from the photogrammetry process. Okay, very high quality mesh. Can add the color or the texture as well. And now I can easily navigate between these drone scans on your static scan. If I go to this one, this is a static scan now. I can easily navigate my project, be able to move from those various static scans or go back to any drone scan. Very interesting way of navigating complete projects that can have static scans, mobile scans, or drone data in a single coordinate system. So this is what I wanted to show you today with regard, but now let's speak quickly about how you can export scan data as well. So I mean, this piece of the process, the first one you may want to do is get back your point cloud, your scan data as a point cloud, because you need to use them in Revit or Navisworks. In which case, the person requesting that will be using Cintoo Connect again, locally on his or her machine to be able to generate those files. The way it works, for example, for structure scans, You will be selecting a set of scans inside the Cintoo Cloud user interface. You say export scans, and that will trigger again Cintoo Connect, where you will be able to select either structure or unified. And if it's structure, you will be able to select either E57 or RCP as output format. Very easy to do. Then you get back your point cloud as if that will be exactly the same as the source point cloud you had at the beginning. Now, when it comes to exporting unstructured data as a point cloud, first thing you may want to do is create crops. So we have a very efficient crop tools now inside Cintoo Cloud. Let me show you a quick example of that. Let me switch into this quick example here, a small example with only 14 scans. We just released lately a new 3D crop tool. So this is the data I've got. If I click on the crop tool here, you have the option to use this bounding box to create your crops. And you press Shift to get the other face of the rectangle. Or you can also use those sliders, okay, which makes it very easy to create crops as well, because on those sliders, you can either use a slider this way, or you can also put numbers into this text field here. So you can copy paste, for example, if you want to create adjacent sections of your data, this is how you would do that. And this is how we've done that for example, cropping equipment like this one or this one. Let me remove the bounding box here. So we just created this crop. So we created a few equipment to be able to export that as a point cloud or as a mesh and put them back in Navisworks. We created also sections of the walls. So this is one section, this is another section. We just exported this. So what happened next is that for each one of those crops, you have the possibility to export it as a point cloud. So you click on export. Again, that will trigger Cintoo Connect to do the inverse mesh to point cloud transformation. And you can get the data back as an unstructured file, being E57, RCP, RCS, with or without decimation. Or you can also ask to request to create a mesh, okay, a unified mesh. So the unification process is something that will run in the cloud, okay, that will do the unification. What we call unification is to take the best mesh contributions from each scan data that you have to create a single mesh that has the best possible quality. Okay, so the way it works, you click on create mesh. That will start a pop-up that will open a pop-up to say create mesh, where you can select the mesh resolution, going down to the resolution of the scan, or you can also select the mesh format, being SDX, OBJ, or STL. So this is what we did in this example here. We have now the data back in Navisworks. On here in Navisworks, we have a set of data that has been exported from Cintoo Cloud. And you see that each mesh section is adjacent to the next. So everything we do when exporting data from Cintoo Cloud is geolocated, being point cloud or a mesh. So when you bring back each adjacent section into Navisworks, they will be exactly at the location they need to be. And that's also the same for this additional indoor equipment. So we computed those meshes with a very high resolution for those equipment, like something like one triangle every 2 millimeters. But for the walls on the rest of the building, we created a mesh with only a resolution of one face every 5 or 2 inches resolution. So you can mix the resolution of your mesh data and have the possibility, like in Navisworks here, to toggle on off the various display of those various meshes. In this other example, we also extracted a section, a horizontal section of your file of the data as a mesh. Okay, and we added a new design. This is a CAD model that I need to add to this boiler room. Okay, here what we wanted to show is that using a mesh to detect your clashes with your existing conditions makes it much easier. Okay, here you see clearly the collision between, or the clash between your mesh, your existing conditions on your CAD model. Now you can also use a point cloud to do this. This point cloud also was exported from Cintoo Cloud as a RCS file. but you'll see that the point cloud will give you a match. The interpretation of the data is much more difficult with the point cloud, of course. So this is just to show you that a mesh can be also useful for clash detection in Navifor. Okay, so a few minutes left. I'd like to show you quickly what is coming in the next few weeks, what you can expect from Cintoo inside Cintoo Cloud. The first interesting feature will be in a few weeks, the possibility when you upload a BIM model from BIM 360 or being a Revit model, Navisworks model, or an IFC model, to be able to get them with the BIM disciplines of the BIM metadata. So that inside Cintoo Cloud, you will be able to toggle on off the various disciplines, or you will be able to click on objects or pieces of the model to get the metadata. And that will be very useful when you do your comparisons, your analysis, or when you manage your assets in the existing conditions. This is coming in the month of May 2022. Another interesting feature is about asset management, the possibility to display the assets in their existing conditions. We do it either by manually tagging those assets in the user interface, or we do this by importing a list of assets coming from your CAD or digital twin platform that will give the ID of the equipment, the exact XYZ location. So you will be able to view and display your assets in the scan data. Or we do this as well by detecting automatically some equipment inside your scans using AI. Okay. So stay tuned on this one. This is a new set of features coming in the next few months for asset management. And of course, the goal here is to link Cintoo Cloud to the digital twin platform, be able to go to close the loop between your digital twin platform or your documentation platform and the existing conditions. Last but not least is everything we do around streaming high-resolution 3D meshes in game engines like Unity or Unreal. This is about getting the as-built conditions in your VR scenario. Okay, you know that bringing existing conditions like scan data in VR is not an easy task. You have to spend weeks of optimizing, the mesh or the texture size and things like that to make your data real-time compatible. Here we do that by streaming, so you don't have to care about the size of the mesh. You have the same experience than in the web app. You will be streaming the scan data in the highest possible mesh resolution at all times, based on the user's point of view. And then you can enrich these existing conditions with all kinds of 3D animations to create very rich experiences. Let me show you a quick example here. Here, we're streaming live scan data from the cloud, from Cintoo Cloud. And there has been this animation being created inside Unreal, a very simple animation where you see this truck is moving now inside the scan data for a delivery scenario. Just to show you that creating this kind of experiences is done in real time almost. You don't have to spend any time dealing with the existing conditions. They are streamed live from the platform. And of course, we can also detect collisions between the mesh coming from the scans on the animation. And that's about it. So thank you for listening. Next steps will be for you, if you're interested, to start a free trial. You go to our website, cintoo.com, you go to the try section. You will be able to upload your own scans. We have a limit at 20 scans today, but if you need more scans for trial, the trial is about 30 days. You can certainly ask the sales team and they will extend your scan capacity. Everything about pricing as well. The way we monetize Cintoo Cloud is only by the number of scans to be uploaded. Okay, we have tiers started at 500 scans up to 200,000 scans. Whatever the size and the resolution of those scans. And this is for unlimited users on unlimited projects. So feel free to invite as many users as you want to your project. This is really about adoption. Any other question, please feel free to ask to sales@cintoo.com. I'm ready to answer a few questions if there are any. Rob?
There were 5 questions, and I believe you answered them all during your presentation.
Can I repeat maybe the answers for the rest of the team, or what?
Yeah, they can see them, but one question was is can they move the CAD or 2D model to the point cloud, or can you move the point cloud to the actual model itself?
Yeah, yes, we do provide on a 3D manual alignment tool inside the user interface of Cintoo Cloud, so you can do that pretty easily. Now, this is not a registration process, okay? So you don't use it for registering various scans together, but this is a pretty easy tool to use when you need to align a BIM model to the scans, or the other way around, a scans to a BIM model.
And just one other question, when will we support .las file import?
Yeah, .las is also on the roadmap for Q2, Q3. So this is part of the of what we do for unstructured scans. So you will be able to get LAS files in the next few months. Absolutely.
Okay, those were really the only two that kind of stood out. Everything else you covered very well during the presentation.
Okay, I will save you a few minutes then. Thank you very much for listening today, and I hope you learned something interesting. And feel free to come back to us for any further question or information. Thank you.